4-6, congruence in overlapping triangles. Okay, so example 1, figure ABCD is a rectangle with diagonals AC and BD. Why is it important to identify corresponding parts of overlapping triangles? Okay, so first thing we're going to do is we will create a couple of triangles. Bring this over here, do the same thing for this one. Not 100% perfect, but it'll give us the idea. Then we'll mark our congruency. So this is congruent, congruent, congruent. This is 90, 90. And then I also know that BC would equal BC. So this is congruent to this. All right, so we're going to identify all of our corresponding parts. Let me label these. A, B, C, B, D, C. Okay. So angle ACB is congruent to angle DBC. Angle CBA is congruent to angle BCD. Angle BAC is congruent to angle CDB. Our sides that are congruent, AC is congruent to DB. CB is congruent to BC. And finally, BA is congruent to CD. All right, try it. What are the corresponding sides and angles in FHJ? So FHJ, and then triangle KHG. So we're trying to find our corresponding parts here. Okay, first thing I'm going to do is separate these by sketching them out. So FG, HJ. Okay, there's one. FH. And then this one. Oh, switch this. And then we know that this side would be congruent to this because they gave us our segments that were congruent. We can use segment addition to add them together, and we would know that those two are congruent to each other. All right, so let's identify corresponding sides and angles. All right, so I know that angle HFJ is congruent to angle HFG. So this angle here is congruent to this one. This should be a K. No, that's not K. Hold on. This should be HKG. HKG, yep, there we go, okay. So then our sides that are congruent, we know that GL GL, this one is congruent to KL. We know that K hold on. I messed this up. Okay, this is not okay. GL is congruent to JL. And KL is congruent to FL. FJ is congruent to KG. HJ would be congruent to HG. And FG would be congruent to KJ. Okay, some more of our angles. Angle FHJ would be congruent to angle KHG. So FHJ would be congruent to KHG, which would also be right here. And then angle HJF would be congruent to angle HGK, which would be this. Okay. All right, example 2 is angle EGD congruent to angle EFH. So EGD, this one, we're trying to prove if it is congruent to EFH. So we're trying to prove those two congruencies. All right, so I'm going to do a 2-column proof. I'm going to start off with the information that I'm given. So I know that DE is congruent to EH. Okay, and because those two sides are congruent, I know that angle D would be congruent to angle H through isosceles triangles, so definition of isosceles. Change my color. So I know that this is congruent to this. Three, I have another given, so DG is congruent to HF. Four, I now can prove triangles, so I can prove that triangle EDG is congruent to triangle EHF. I can prove those through side, angle, side, because I have a side, I have an angle, and I have a side. And then finally, I can prove angle EGD is congruent to angle EFH. And that would be through corresponding parts of congruent triangles are congruent. Let's try it. We want to see if VW is congruent to ZY. I'm going to start by separating my triangles here so I can visualize this better. Now I'm going to start writing a proof. My first will be what I'm given. And I can see here that I have angles that are congruent. So they are telling me that angle WVZ is congruent to YZV. So these two angles are congruent. So W angle WVZ is congruent to angle YZV. And that was given. I know that VZ equals VZ because those two are the same side, so it's reflexive property. So VZ is congruent to VZ. Okay, they told me that angle WVX is congruent to angle YZX. Okay, because they gave me that previous angle, I know that angle WZV is congruent to angle ZYV. So angle WZV, this section right here, would be congruent to this. Okay, and I know that through the angle addition postulate. Okay, and I can use the angle addition postulate because angle WVZ equals WVX plus angle YVZ. Okay, so if I add these two angles, this angle and this angle together, it gives me the entire angle. So that's all I did right there, is I used the angle addition postulate and I backed out the information that I knew. Okay, 5. Now I can prove my triangle, so I can prove triangle VWZ is congruent to triangle ZYV. And I can do that. I didn't mark it on here because now I have angle, side, angle. Finally, they wanted me to prove VW is congruent to ZY. And I can do that through corresponding parts of congruent triangles are congruent. All right, so now we are given AB is congruent to DC, AF is congruent to DE, and angle A is congruent to angle D. We want to prove that BFE, so BFE, this triangle, we want to prove that triangle is congruent to CEF, this triangle. Okay, so I'm going to start with my proof, my 2-column proof. Okay, so our first is going to be what we were given. We are given AB is congruent DC, and all right, 2. We know that FE is the same as FE. 3 reflexive. 3. AE would equal DF through angle addition postulate. So I can add AF plus FE to get me AE, and then I can add DE plus FE to get me DF. I can prove my triangle ABE is congruent to triangle DCF because I have a side, an angle, and a side. I can prove that BE is congruent to CF. And that angle BEA is congruent to angle CFD. So I can prove BE, that whole thing is congruent to that whole thing, and angle BEA, this angle is congruent to this angle. I can do that through corresponding parts of congruent triangles. Finally, I can prove that triangle BFE is congruent to triangle CEF. All right, and I can do that through side angle side because I have a side, I have an angle, and I have a side of this triangle. And then I have a side, I have an angle, and then I have a side of that. Okay, our try it. We want to create a proof to prove triangle SRV is congruent to triangle TUW. All right, we always start off with some of the information we're given. So they told me that SR is congruent to TU and angle SRW is congruent to angle TUV. Angle SWT is congruent to angle TVS. Angle STW is congruent to angle TSB. Those are all given. Okay, next I can prove that ST is congruent to ST. That's through reflexive. Three. I can prove triangle SWT. SWT I can prove is congruent to triangle TVS. TVS. And I can prove those through angle, so angle, side. Or on this one, it would be angle, side. All right, next I can prove that SV is congruent to TW. That is through corresponding parts of congruent triangles are congruent. So 1, 2, 3 would be congruent to this. Next, I know that angle SRV is congruent to angle TUW because they are both right angles, and right angles are always congruent. And then finally, I can prove triangle SRV is congruent to triangle TUW. And that would be through hypotenuse leg, because we just proved the right angles were congruent. Example 4. A city runs 3 triangular bus routes to various attractions. How can you draw a separate triangle for each route? Are any of the routes the same length? So first we're going to look at the green route. So the green route goes from the Science Museum to the theater to the History Museum to the zoo, Rose Garden, and then back to the Science Museum. Okay. So that is my green route. Go ahead and label the sides here. So I have 2.1 plus 1.4. 1.2 plus 0.9. This is a right angle. All right, our next route is from the water park to the art museum. To the concert hall, to the science museum, to the zoo, and then back to the water park. Ooh, it's a rough one, but good enough. Okay, so those measurements are 1.6 plus 1.2 plus 1.6, and then 1.4 plus 1.1 plus 1.4. Okay, then our red route. So our red route goes from the football stadium to the zoo to the theater, science museum, Rose Garden, and back to the football stadium. Okay. So those measurements are 2.1, 1.2, missed a point there, 1.2 plus 0.9 plus 1.1 plus 0.3. So once I add these together, I would get 3.5, 2.1 over here, 3.9, 4.4, and this is 3.5. And they wanted to know if any of the routes were congruent. Oh, I missed one side here. Down here, this is 0.9 to 1.8. That one would be 2.9. All right, so they wanted to know if any of our routes were congruent, and I can see that my green route and my red route are congruent. All right, our try it. A new route will stop at the History Museum, Water Park, Zoo, Science Museum, and Theater. Draw a triangle to represent the new route. Include any links and angle information that is given in the diagram. So let's create a triangle. So we are going from the History Museum to the water park, to the zoo, to the science museum, to the theater, and then back. Okay, so we're creating a new route. covers this. And then I want to include my measurements on this. So 2.1, 1.4, 2, 6. Okay, so then when I combine those measurements, I would get 3.5, 4.4, and then the 2. Okay, so that would be our new route measurements.